The lesson outcome for this video is I can write equations of parallel lines. The two lines on this coordinate plane, the red one and the blue one, look like they might be parallel. Now, what is the definition of parallel? Parallel lines are two lines that never intersect, right? Never intersect, which means run into each other or cross. Okay? So how can we be sure that these two lines will never intersect or cross? Well, we could write the equation of them and take a look at the information that we see. So first of all, let's look at the red equation. I could write this equation in slope-intercept form, or I could write it in point-slope form, all these forms that we've been practicing. I'm going to choose to use slope-intercept form, y equals mx plus b. So my b value here, my y-intercept, is right here, and that's at 4. So I'm going to go ahead and put a 4 in for my y-intercept, and now I'm going to count my slope. Okay? From here, I have to go to another point somewhere up here, so maybe let's use this point right here. There's another point. So I'm going to count from here. Let's see, where's my green arrow? From here, I'm going to go 1, 2 to the right, or sorry, 1, 2 up, and then 1, 2 to the right. So my slope was 2 over 2. So now if I write my slope as 2 over 2 right here, I get y equals 2 over 2 x plus 4. In other words, y equals 2 over 2 is 1, x plus 4. Now, let's do the same thing for our second equation, our blue equation. Our blue line, my bad. So y equals mx plus b again. My y-intercept is right here, which is 1. And a point on the line, I'm going to use, let's see here, I'm going to use this one right here. So my slope is 1, and my y-intercept, I apologize, you guys. My y-intercept over here is 1. And now my slope, if I start here, I can go 1, 2, 3 up, and 1, 2, 3 over. So I've gone up 3 and right 3. Well, what's 3 divided by 3? 3 divided by 3 is 1, so I have 1x plus 1. Now, if we compare our two equations, what we're going to notice is that they have different y-intercepts, which is pretty obvious from the graph, but we do notice that they have the same slope. And that same slope is the reason that they will never intersect. Their slope is 1. So if I went from here and I go up 1 and right 1, up 1, right 1 here, and I go from here up 1 and right 1, I'll notice that if I keep moving up and right, 1 and 1 over 1, 1 over 1, the two graphs in no way could ever cross because they rise and run at the same rate. So the important thing to remember about parallel lines, very important, okay? Parallel lines have the same slope. Parallel lines have the same slope. And that's kind of a key to what we're doing in this section. Okay, so let's just try a couple of quick examples on naming the slope of a line and then naming the slope of the line that is, any line that is parallel to that line. So the first one we have is y equals 3x minus 4. The first thing I'm going to do is I'm just going to name the slope for each of these lines. This first line is in slope-intercept form, y equals mx plus b, and we know that this then is our m, or slope, so 3. The second equation is in point-slope form. Point-slope form always has our slope right here in front of the parentheses, so negative 2. And our slope of the third one, we're back to slope-intercept form, and again, our slope is the number in front of the variable x. So negative 2/5. There's our slopes. So now, if our job is to answer the question, what is the slope of every line that is parallel to this first line, we can think about what we notice on the first slide, and that is that when two lines are parallel, they have the same slope. So every line that's parallel to this line will have a slope of 3. Every line that is parallel to this slope will have a slope of -2. Every line that's parallel to this line will have a slope of -2/5. Again, you'll see that their slopes are the same. Okay, so let's try a few examples of writing an equation with some information when lines are parallel. All right, so number 1, write the equation of the line that is parallel to the line y equals 5x minus 3 and goes through the point 6, -2. One thing to remember is that when we know a point that a line is going through, we're always going to want to use point-slope form. It's pretty simple going that way. So what we're going to do here is we're going to remember that if we're using point-slope form, which is what we're going to do on all of these, we need to write down the point that we're going to use, and we need to write down the slope that we're going to use. So what's our point and what's our slope, and then we'll be able to write the equation. So the point that the line goes through is 6, -2, and then what's the slope? Well, here's the key. We want to write the equation of a line that's parallel to this line. What in this equation helps us determine the slope? Well, if they're parallel, they have the same slope. So m is going to be 5. So now we're going to go ahead and write our equation. Let's see. Okay, we're going to use point-slope form. Remember, y minus y1 equals m times x minus x1. I'm going to put my slope in for m right there. We need the parentheses here, and we need the y out here. So now we got to put our x1 goes in and our y1 goes in. So our x is going to go over here in the parentheses. Again, if the 6 right here is positive, we're going to put this in as -6. And then since our y value right here is -2, we're going to put in +2 with our y. So here's the equation that is parallel to the line y equals 5x minus 3 that goes through point 6, -2. Now we're going to do the same thing for 2, 3, and 4. Why don't you try them, write them down, and then check back to see how you did. All right, so number 2, write the equation of the line that is parallel to the line y equals -2x and goes through the point -1, 7. So again, parallel to this. That means our slope is going to be the same slope as this line, which is -2. And our point that we're going to use is the point that it says it goes through, which is -1, 7. So to write this equation, we're going to write y minus 7, again, here's that 7y value, so it's -7, equals -2, our slope, times the quantity x. And then since this right here is a plus or -1, we're going to write +1. Okay, the next one, we want to write the equation of the line that is parallel to this line right here and goes through the point -3, -9. Again, we need a point and we need a slope. Well, our point is -3, -9 that it's going through, and our slope is the same slope as this equation has because they are parallel. They're going to be parallel. So -8 is our slope, so we're going to write that in right here. And we're going to write our equation. So y plus 9 equals -8 times x plus 3. And the last one. Okay, write the equation of the line that is parallel to this line. And this one's a little different. Has a y-intercept of 9. If we don't have a point, we probably won't be using point-slope form. If we have a y-intercept, probably the best thing to do would be to use slope-intercept form. So if we want to write this equation in y equals mx plus b form, we need to know what is m and what is b. We want the slope to be the same slope as this line right here because they're parallel. So the slope is this number in front of x, which is -1. The b value of our new line, because it says we want to write the equation of a line that has a y-intercept of 9, we know our y-intercept is going to be 9. So we're going to write y equals -1x plus 9.